Hello, this is Mr. Stansbury. I'm going to take you through the notes on finite geometric series. At the end of this, you should be able to say, I can find the sum of a geometric sequence, the formula for a geometric series, or the number of terms in a geometric series given terms of the sequence. Okay, so first things first. A geometric series is the sum of the terms of a geometric sequence. Okay, an infinite geometric series is the sum of all the terms of an infinite geometric sequence. So there's an endless amount of these terms here. All right. For a finite geometric series where r, the rate, is not equal to 1, because that would just be the same number over and over again, is going to be either this or that. And really the only difference on this that I could find is that it's the rate minus 1 or 1 minus the rate. Okay, it's basically these two are the exact same formula, just changed around a little bit. So let's take a look. I'm going to elect just to copy down the first one. I'm just going to use that same one over and over again, and I think we'll be good. Okay. Example 28, find the sum of 1 plus 2 plus 4 plus 8 all the way up to 15 different terms. Okay, so let's use our formula here. So we have S of n is the first, our sum is going to be the first term, which we know is 1, plus the rate. Okay, so now we got to figure out what we're doing each time. So remember to figure out the rate: 2 divided by 1, 4 divided by 2, 8 divided by 4. All of those are going to be 2. So we're multiplying by 2 each time, right? 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, so forth and so on. So that means that our rate is 2, and then our n is our number of terms. In this case here, it's 15, and then we subtract 1, all over our rate, which is 2, minus 1. And now we just simplify. Okay, so that's just going to be 1 times, that doesn't do anything, so it's basically 2 to the 15th minus 1 all over 1, so it's just 2 to the 15th minus 1. Okay, so 2 to the 15th power, and then minus 1 should give us our answer. 32,767 is the sum of the first 15 terms. Okay? Okay, let's take a look at another example here. Number 29. Find the formula for S of n of the series 12, negative 6, 3, negative 3 halves, all the way on to infinity. All right, so let's see. Let's use our formula here. S of n equals the first term, which is 12, all times the rate. So we got to figure out what the rate is. Negative 6 divided by 12 is negative 1/2. So it looks like we're multiplying by negative 1/2 each time. Negative 6 times negative 1/2 is 3. 3 times negative 1/2 is negative 3/2. So there's our rate. Negative 1/2. I'm going to put 0.5 all to the n. We don't know the number of terms. Minus 1 all over our rate, which is negative 0.5 minus 1. All right, let's simplify this as much as we can. 12 times negative 0.5, minus 1, to the n, minus 1 all over negative 0.5 minus 1 is negative 1.5, right? So really all we're going to do is just simplify this by doing 12 divided by negative 1.5. And that gives us negative 8 in this case. So we get S of n equals negative 8 times negative 0.5 to the n minus 1. Okay? We could distribute this through and get negative 8 times negative 0.5 to the n, and then negative 8 times negative 1 is plus 8. We could write it either way. I'm not sure which one's easier. Honestly, I think this is probably a little bit better, but either one of those would work. And that's our formula. So then all we'd have to do is get our n, and we could plug our n in and then calculate, and that would tell us what the sum is of all those numbers there, all that entire series. Okay, first let's take a little quick comedy break here.
Okay, stop. Let's see what happens. Oh.
All right. Let's see. Let's take a look at our next example. Lefty just got himself a new pet Steve, a pink fairy armadillo. The monthly cost for Steve for everything is $600. That says the monthly cost, so let's get rid of monthly. So the cost for Steve is $600 a year. Every year, the yearly cost goes up by 4%. How much did Lefty spend on Steve in year 5? Right. So we got that he spent $600 the first year. Right. So for part A here, let's do our S of N. Let me see. How much did Lefty spend on Steve in year 5? So it's just actually the 5th year. So we don't necessarily want the sum. We want the u sub n, which is our u sub 1 times the rate to the n minus 1 for year 1, right? Yeah. So u sub n, or in this case here, we're going to do 5. The first term was 600. The rate is going up by 4%, so that's 100%, because you're still going to spend the $600 plus 4% each year, so that's 1.04. And then we have to the nth term is going to be 5 minus 1. Okay, so that's how much they're going to spend in year 5. So let's calculate that out. So we got 600 times 1.04 to the 5 minus 1, or the 4th power. Gives us, in year 5, it was $701.92. So year 5, $701.92. So that's how much she spent. Let's see, part B. Write an expression for the total cost for Steve during the first n years. So that's where we're going to use this, right? So S of n equals first term, which is 600, times our rate, which is 1.04, to the nth power, and that is all that in there minus 1. And that's all over our rate, which is 1.04 minus 1, right? So there's our expression for